Hello everyone! Today's lesson is going to focus on breadboards and how they function. Now, we discussed breadboards early on very briefly and how they are interconnected. This is going to be kind of a review of that information and making sure that you have a thorough understanding of how a breadboard works internally so you can use it to create some circuits in Tinkercad. So make sure you are taking notes, make sure you document and understand how a breadboard works, and let's get started.
This lesson is 1.1.5 and focuses on breadboards and how we use them. So in this lesson, you will learn how to explain what a breadboard is and identify the reasons for using a breadboard, as well as review the proper guidelines and tips for proper breadboarding. So what is a breadboard? Sometimes breadboards are also known as protoboards, and they are a reusable platform for temporarily building electronic circuits. You can see the image of a standard breadboard below. So how does a breadboard work? Well, the electronic component leads and the wire used to connect them are inserted into the holes that are arranged in a grid pattern on the surface of the breadboard. You can see that in the top view. We have the top bar, as well as the bottom bar, and a series of rows identified by letters inside of that breadboard. Inside of the breadboard, a series of internal metal strips serve as jumper wires, and they connect specific rows of holes. If you look at the cutaway view, you can see this bar right here actually lines up with this bottom row. That indicates that there are internal metal wires that connect each of these holes to the next one. That means if we were to plug in a jumper wire at hole 1 and it was connected to power, we would have power running through this entire row. Additionally, you can see that every column is connected. So that would mean that if we have power running through J, we also have power in I, H, G, and F. There is a break in the center of the breadboard, so E, D, C, B, and A would not have power. Here's another illustration of breadboard connections. Typically on a breadboard, these top two rows are labeled as positive and negative. This is typically where we jump power to. Typically you have the same two bottom rows down here. And once you have that power in, there's power running through all of these. We then have to create our circuitry inside of the remaining portion of the breadboard. Frequently, we put components across different columns because that's how we can have the connection flow. Remember that a circuit of electricity is exactly that, a circuit, a loop. So if power comes out of hole 1, and let's say we had a resistor that was in 1B and then in 2B, we would have to then go into 2A to continue the circuit either back to negative power or to our next component. So why do we breadboard? We breadboard because it takes less time and money to breadboard a circuit than it does to design and fabricate a printed circuit board or a PCB. Because of the cost, a PCB is always reserved for the final working design. As a complement to circuit simulation, breadboarding also allows a designer to see how and if an actual circuit functions. Breadboarding also gives a designer the ability to quickly change components during development and testing, such as swapping out resistors or capacitors for different values. And breadboarding also allows a designer to easily modify a circuit to facilitate measurements of voltage, current, or resistance. When we use a breadboard, it's always good to use as few jumper wires as possible. Inside of Tinkercad, this means thinking about where you're placing things so we have as few wires clicked on as possible. The breadboard should be used to make the majority of the connections between the components, meaning we always want to stagger our pieces so that they're connected inside of the rows and continue to the next row. You want to keep your jumper wires as short as possible. A jumble of wires is difficult to troubleshoot. The same thing goes in Tinkercad. Keeping the components closer together on the breadboard can be easier to see where your circuit is going. If we have a lot of components, we're going to need to spread out across the breadboard in order to be able to see things, but we want to make sure that we're staying as organized as possible. Also, you want to make sure that you're laying out your circuit in a way that it looks as close as possible to the layout of the schematic, so that way you can follow along and make troubleshooting easier if something isn't working correctly. Also, IC chips should always go in the middle of the breadboard. We haven't talked about IC chips yet, but when we get there, I'll make sure I demonstrate that for you. Also, you should always work from a schematic and check off the component and wires as they're implemented on the breadboard. Taking screenshots of our circuits and then using an application like Google Draw to be able to highlight when you've inserted something is a good practice. Also, make sure you cut component leads to manageable lengths. Now, that's not an issue because we're doing this in a simulation, but when we get back to the classroom, we will need to make sure that we don't have a lot of wires sticking out, otherwise they can touch each other and short circuit. Also, if you're struggling with a circuit, it's always good to have someone else check your circuit for errors. When you're designing a circuit, it's very often that you will not see the mistake you made because you're the designer. Okay, so let's take a look at how we would actually set up a breadboard inside of a simulation like Tinkercad. First, we have to make sure that our components are set to all and not basic. So inside of Tinkercad, there are actually 3 different size breadboards. They are all located pretty far down in the components list, but you have a standard breadboard, a breadboard small, and a breadboard mini. I recommend consistently using the full-size breadboard as it is closest to what we would be using in class. Just click and drag it over, and as you can see, just like in our presentation, we have our negative power and our positive power located both at the top and the bottom. You'll notice that when I hover over any of these holes, it shows me what I'm going to be connecting by placing a component or wire into that hole. The same thing occurs when I move to the center of the breadboard. It shows me the various columns and how they're connected. So now let me grab a component. I'm just going to scroll up here and I'm going to grab a resistor and I'm going to place that resistor into the circuit. Now I'm going to rotate that component because I want it to go across 2 different columns inside of the breadboard. Remember, one of our breadboarding tips is to keep components as close together as possible. For the purposes of this presentation, I am going to just grab a light bulb and I'm going to place that light bulb inside of the circuit. Now you'll notice that I'm placing this in right next to, if I zoom in, my resistor is here, okay, and then the terminal for my light bulb is in the same column. That is so I do not need any additional jumper wires. Now, if I'm going to complete this circuit, I'm going to need some form of a power source. So I'm going to come over here to the menu, just really quickly, and I'm going to grab the same power source that we used for our pre-assessment. I'm just going to leave it at 5 volts for now. We can play with that voltage later once we start the simulation, but this is where I actually need wires. So my red wire has to go to the positive, and then my black wire needs to go to the negative. Now I'm going to zoom in on this circuit, and I'm going to connect positive power to this end of the resistor. And then I'm going to come over here and I'm going to connect, wishfully thinking I'm going to connect. I'm going to move the bulb temporarily. I'm going, because I know this is the column that the bulb is going to be in, I'm going to connect this bulb to my negative power, and then I'm going to slide the bulb back into the circuit. Now when I hit start simulation, the bulb illuminates because I have a completed circuit. I'm going from my positive power into the breadboard here. That is then traveling to this jumper wire, which is going to this side of the resistor. The power is traveling through the resistor into terminal 1 of the bulb. From terminal 2 of the bulb, it's coming back out of that jumper wire that I placed and back into the negative power at the top of the breadboard. As you can see, I used as few jumper wires as possible. The only wires I used were to literally go from the power supply to power, and from the power to the components and back. That's the ultimate goal. You always want to keep your components blocked out in a way that we use as few jumper wires as possible.